Hi everyone, we're going to be working on Learning Target 2 from Unit 7, which is I can describe and predict the effect of a rigid motion in terms of congruence. So we've learned in the past that two geometric shapes are congruent if they have the same size and shape. We use the congruent symbol to stand for congruent because it combines the equal sign, which indicates the same size, with a similarity symbol, which indicates the same slope. So looking today at sequences of transformations, we're going to be looking at what's the outcome when we do multiple transformations to a single pre-image. So for our first example, we have triangle XYZ with vertices x at -3, 7. So at -3, 7, that is x. 2 is at -2, 1, or y is at -2, 1, and z is at -5, 2. All right, and we are going to first reflect in the x-axis, and then we are going to translate with the rule x plus 9 and y plus 2. So the first thing that it states is to reflect in the x-axis, so we need to think to yesterday or last week when we were reflecting. The x-axis, again, just a reminder, is your horizontal axis. To reflect y, I notice that y is 1 unit above the x-axis, therefore y is going to, or the image of y is going to be 1 unit below, and we can do that for all of the others. I'm not going to spend a lot of time today talking specifically about that, just because we did a whole lesson on it last week. 1, 2, 3, 4, 5, 6, 7. Okay, so that's our first transformation. However, we're not done, and which is why I did not fill that shape in completely. We now need to take that new shape and translate it using the rule x plus 9, y plus 2. So I'm going to count 9 spaces to the right and then 2 units up. So for y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2. So the image of y maps to 1, 2, 3, 4, 5, 6, 7, 7, 1. If I were to do that same process with x, it would be here. So the image of x would be there, which would be 6, 1, 2, 3, 4, 5, -5. And then z, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2. Image there, or image of z is there, and that would be at 4, 0. And I should notice, if I did everything correctly, that I have 2 congruent figures that I have just performed a sequence of transformations with. Okay, so I would say, because they are congruent figures, that triangle x, y, z is congruent to triangle image of x, or x prime, y prime, and z prime. And that would be my congruence statement. That will come in handy as we move forward with our geometric proofs. So make sure that you're understanding that I am putting the two triangles congruent to each other, and the x's are obviously the corresponding parts, the y's are the corresponding parts, and the z's are the corresponding parts. Looking at example 2, we're going to graph another triangle. So we have GHI, vertices for G, -1, 6, 1, 2, 3, 4, 5, 6. And that is G. H is at -1, 3. And I is at -6, 6. 1, 2, 3, 4, 5, 6. And that is your pre-image I. And if you did everything right, it should be a triangle. Okay, and our first transformation that we're going to be doing is a translation along a vector of 7, -5. So remember, the first number is your horizontal component, and the second number is your vertical component. So if I'm going to be moving 7 horizontally, so 1, 2, 3, 4, 5, 6, 7, I'm moving G first and then down 5. 1, 2, 3, 4, 5. So my initial image of G would be there. If I'm going to do that same thing for H, and this is where G I can see is 3 units above H, so I don't necessarily have to count my spaces. I can just visually tell that it's going to be 3 spaces below, because again the figures are congruent. And the same thing with I. G and I are 5 units apart, so I can just include my image of I there. Now again, this is kind of the pre-image, so I'm not going to fully fill in that triangle because I know that that's not where I'm stopping. I have another transformation to do. So my other transformation that I need to do is reflect in line y equals -3. So remember, y equals -3 is going to be a horizontal line, so I'm going to be reflecting horizontally, and y equals -3 on the y-axis right there. So any line along that horizontal line is going to be equal to y equals -3. So I need to then reflect. And again, I can see that h is 1 unit above, so the image of h will be 1 unit below. And then I can continue that with my other points. So I is 1, 2, 3, 4 above, 1, 2, 3, 4 below. And make sure that you're including your tick marks with your image so that we can identify which is your pre-image and which is your image. So that would leave G at 1, 2, 3, 4, 5, 6. So 6, -7. Is that -7? 1, 2, 3, 4, 5, 6, 7. Yep, -7. H would be at 6, -4, and then I would be at 1, -7. Okay, so for this last one, I want you to try it on your own. I want you to pause the video here, go through the whole process, and then check back in. I will do checkpoints after each transformation so that you don't go through the whole problem, potentially making a mistake at the beginning. So go ahead, pause your video, and record your initial rhombus, and then do your first transformation for letter A. Okay, so you should have your pre-image rhombus PQRS. You'll notice that towards the bottom of your coordinate grid, and then after the translation along a vector of 4, 10, you'll notice that your image has shifted to the first quadrant. So double check and make sure that you have what I have. And now I want you to go and do your transformation for letter B, which is a 90 degrees counterclockwise rotation about the origin. So our rotation rules apply here because it is about the origin. Okay, so go ahead, pause your video now, and see if you can do this independently. Okay, so hopefully if you are taking a look, you see that letter B, your 90 degrees counterclockwise rotation about the origin shifts your image to quadrant 2. So P, after our translation in A brought P to 3, 7, because of our rules, remember that we switch the order and the new x becomes negative. So Q is now at -6, 7. R is at -2, 8. And then S is at -3, 4. Okay. If you have any questions, that's the end of our notes. Make sure that you save your notes because last week a lot of students mentioned that they completed them, but then when they uploaded them, their notes were not there. And if that's the case, sorry guys, you got to do it again. So make sure that you are saving your notes and then uploading them to Google Classroom to submit. Some people are forgetting to submit, and I do not have the time to go back through all of your unsubmitted work. So you need to make sure that you submit it when you're ready for me to look through it. So submit your completed notes, make sure you save a copy for yourself, and then you're going to go on to Delta Math to complete your practice. Now in Delta Math, there will be some dilation questions in there. Unfortunately, it was kind of clumped. I wasn't able to separate it. But just remember, if a dilation is one of your transformations, it is not the same size. So if you have a pre-image and image, and they are different sizes, you know that one of your transformation is going to be a dilation. And that's something that we went through with um, your eighth grade summer course. So just be aware of that. And you have to get, I believe, 10 problems correct, and then you are done with that. You do have a quiz on Thursday covering Learning Target 1 and 2, and then what we're learning tomorrow, Learning Target 3 with angles. There is a study guide posted in Google Classroom as well as on the lesson plans. So if you want to get started studying now, you are more than welcome. So, but that will be on Thursday. But I just want to give you a heads up on that. So, if you have any questions, stop by during Zoom from 12:30 to 1:30. I'm happy to answer them for you. If you have any missing work, make sure you're catching up on that. I'll be filling those grades in on Tuesday. And anything else, yeah, just email me if you have any other questions, and good luck. So I will talk to you later. Bye.